back. We're going to do day 2 of this 9.3 radicals. We're going to learn today how to multiply radical expressions and then how to rationalize a denominator. But first up, we're going to do a little bit of a review. If you recall from the other day, we talked about simplifying these radicals by getting into a perfect square factor. So recognizing your perfect square numbers. And I would encourage you to still do that, okay? So make sure you can recognize all of your perfect square numbers from 1 through about 15 and then 20 also. And then so you can recognize those, okay? So if I were going to do this 84, sometimes what I do is I look at that table and I think, okay, you know, what's 84 divisible by? And so in this case, this 84 is divisible by 4. And so this would break this into the square root of 4 times 21. I need to change my pen sizes here. And then I could break this up into the square root of 4 times the square root of 21. And then, of course, the square root of 4 is 2 times the square root of 21. And 21 is just 7 times 3, so there's no perfect square factors in there, and we're good to go. But what I wanted to kind of show you today is I want to show you an alternate way to reduce radicals in case you can't really think of a perfect square factor. Okay, so maybe you're not quite sure how to do that. And so I want to show you how to do the factor tree. And you may have seen this, you may have not. I know last year in Algebra 1, it didn't quite get hammered enough because the school closure ended up happening. So what I'm going to show you how to do is do a factor tree. What we do is we start with our prime numbers, 2, 3, 5, and 7. And there's more prime numbers, of course, but these are the ones you really don't have to go much past these guys, okay? So we always start with dividing by our first prime number, 2. And I keep all my prime numbers on the left-hand side, okay? So 84 divided by 2, it's going to be 2 times 42, okay? So we kind of break this two number into 2 times 42. I'm going to continue doing that as long as I can divide by 2. And I'm going to keep my prime number all on the left-hand side. So this is going to be 2 times 21. Now notice I can no longer divide by 21, okay? So now I'm going to go to my next prime number, 3. And 21 is going to be 3 times 7. And now I'm all finished, right? So notice I have all my prime numbers here on the left-hand side, okay? So in reality, 2 times 2 times 3 times 7 is called a prime factorization of 84. It's the same thing. And so I can kind of show you this with my calculator if I clear this out here somehow. If I take 2 times 2 times 2, or 3 times 7, that should give me 84, okay? So that's called the prime factorization of 84. It's equivalent to 84. And what I can do here is I know that for a square root, right, this is a pair of 2's. For every pair, I can take the square root because it's the same thing as 2 squared. And what's the square root of 2 squared? Is 2. So know that a square and a square root kind of undo each other, much like addition and subtraction undo each other. Multiplication and division undo each other. A square and a square root undo each other. So if I have this pair of 2's, I can take that and put it outside my radical, okay? But notice that these other 2 guys here, this 3 and the 7, this does not have any pairs. So it has to stay inside my radical, okay? 3 times 7, they have to stay inside, all right? So my simplified answer is going to be 2 square root of 21. And that is my simplified radical. Notice it's the same as that guy up there, okay? So you can do this factor tree for any numbers, especially if you don't have a calculator handy. You can just start breaking it down from 3. As soon as I can't divide by 3 anymore, I go to 5. If I can't go to 5 anymore, I go to 7. But usually I can get through most of these with just these prime numbers here, okay? All right, so now we're going to start multiplying these together, okay? And one rule you have to remember is that numbers outside of a radical cannot play with numbers inside of a radical, or variables for that matter. They have to be, I have to multiply terms that are outside together and multiply terms that are inside together, okay? So these terms here I can multiply together, and these terms here I can put together under the same radical and multiply, okay? So 3 times 2, I can do that here, 3 times 2. And then I'm going to multiply. That's always multiplication, right? This is all multiplication. Even though you can't see it there, that's 2 times the radical, 3 times the radical, okay? And so then underneath the radical here, I'm going to have 5 times 15, which is, what is that? I don't even know. My head's a little late tonight. So we go 5 times 15, which would give us 75, of course. 75, okay? And then x times x cubed is going to be x to the 4th. Now we want to simplify all that stuff, okay? We want to simplify everything in the radical 3 times 2 is 6. Okay, we have the square root of, and of course 25 goes into 75. So this is kind of one you can use a perfect square number. So I'm going to write 25 times 3. You could use a factor tree if you needed to, but try to really identify those perfect square factors because it makes your life a little bit easier than always using the factor tree. Okay, and then x to the 4th. Now the way you take square roots of powers is you're going to take this power and divide by the index. If there's no index here, it's always going to be 2. That's what a square root is. But we don't put the 2 there. If there's no number there, it's a square root. When you get into algebra 2, there'll be a 3 there or a 4 there. That'll be a cube root or 4th root. But if there's no number there, it's just a regular square root, which means it's a 2. So to take the square root of this power, we just take the power and divide it by 2. So it's going to be x to the 4th. Okay. So what we're going to do here is we're going to take, this is going to be 6 again. Okay. I'm going to put all of my perfect squares under one radical. So I have my 25 as a perfect square. My x to the 4th is a perfect square. And then my 3 is not. So I'm going to separate those into a different one. Okay. So 6, remember this is times. Okay. Square root of 25 is 5 times the square root of x to the 4th. Remember that power divided by my index 2 will be x squared. X squared times the square root of 3. Now all I got to do is just finish the multiplication. 6 times 5 is 30. X squared, square root of 3. Okay? If you take these step by step, they're not too difficult. You just have to kind of take them one thing at a time. Okay? All right, let's do one more. All right, so we don't have any other numbers outside the radical other than 2. So we're going to leave that there. Okay? And then we're going to take our 12 times 18. All right? 12 times 18 here is 216. X squared times x to the 5th, we're going to add those powers. So 9 plus 5 is going to be the 14th power. Okay. Now those are two numbers there. Let's see. X to the 14th is a perfect square. I don't know if 216 is. I don't think it is. Okay. So I'm going to take over here and instead of, I don't really know. Let's say I don't know what a perfect square factor is for 216. So this time I'm going to do a factor tree. Okay. So 216, that's going to be 2 times 108. And I'm going to keep going with 2 here. 2 times 54. And I'm going to keep going here. 2 times 27. And now 2, I can't use a 2 anymore. So I'm going to keep going. I'm going to use a 3 now. 3 times 9. And that's going to go 3 times 3. Okay. So notice I have here on my left-hand side all of my prime numbers. Right. So I have 2 times 2 times 2 times 3 times 3 times 3. That equals 216. Okay. So notice I have a pair of 2's here and a pair of 3's that are both perfect squares. So now what I'm going to do here is I'm going to write 2 times, and I have 2 squared, and I have another 2, and I have a 3 squared, and another 3, and I have my x to the 14th. So that's kind of my representing my 216. Okay. So again, I'm going to rewrite one radical with all my perfect squares in there. So my 2 squared, my 3 squared, and then my x to the 14th. All even numbers are perfect squares, right? If it wasn't an even number, I'd want to make it, write it as an even number. And then I have times the square root of, and then 2 times 3 are my ones that are not perfect squares. Now we can continue to simplify. So 2 times, the square root of 2 is 2. The square root of 3 is 3. The square root of x to the 14th, remember I take this 14 and divide by my index 2. So that's going to give me x to the 7th. And then I'm left over here with this radical square root of 6. So 2 times 2 is 4, and then 4 times 3 is 12. X to the 7th, square root of 6. And we are done. Okay? And there you go. All right. Now we're going to learn how to rationalize a denominator. Okay? And so what it is you cannot have a simple radical form if there's a radical in the denominator. So we have to learn how to eliminate that radical in the denominator. Okay? So we have this square root of 2 divided by 3. We break it up into a radical 2 over radical 3. Well, we know that a square undoes a square, undoes a square root. So if we multiply that denominator by itself, that is a square of itself, and that will eliminate the square root because square root of 3 times the square root of 3 is square root of 9, and the square root of 9 is just 3. Okay? So we'll have to do that to the top and bottom. So that's square root of 3 over square root of 3. That's just the number 1. So multiplying something by 1 doesn't change it. So that allows us to kind of manipulate the number and eliminate the radical. Okay. So same thing down here. We just multiply this one by cube, or square root of y cubed, and then do the same thing on the top and bottom. Okay. So we're going to go ahead and practice this. So we have 2 over the square root of 3. We need to eliminate that bottom radical, so we're going to multiply it by itself. So I'm going to multiply by square root of 3 on top and bottom, because the square root of 3 over square root of 3 is 1, right? Okay, so this is going to become top times top, bottom times bottom. So 2 times the square root of 3. You can't multiply the 2 and the 3 together, remember. This is 3 square root of 3 times the square root of 3, which is square root of 9. So it's going to be 2 square root of 3 over the square root of 9, which is 3, and the radical is gone. Okay. This one over here, let's multiply by the square root of 2 on the top and bottom. Square root of 2 over the square root of 2. Okay. 5 times the square root of 2 is 5 square root of 2. Square root of 2 times square root of 2 is a square root of 4. So that's going to give us 5 square root of 2 over 2. Bada boom, bada bang. Okay. All right, you guys might want to go ahead and pause this and try this on your own and see how you do, or just keep going with the video. So here we're going to multiply again by square root of 10, square root of 10. Okay, this is going to give us 2 square root of 10 over the square root of 100. I'm going to come down here really quick. So 2 square root of 10, the square root of 100 is 10. Now notice, I can simplify this further because 2 will go into 10. So make sure you continue to simplify if you can. 2, oops, in the red here. 2 goes into 10 5 times, right? So this is going to be the square root of 10 over 5. Now alert, a lot of people want to divide this into 2. You cannot do that because the 10 is in a square root. That's in jail. 5 is not in jail. You cannot play, okay? So they cannot play with each other. They cannot be divided. Do not make that mistake. If you make that mistake, a kitten dies somewhere, okay? Okay, this one over here, we don't need to multiply by 2 because 2 is not in the radical. The only thing we need to multiply by is just the square root of 3x. That's it, okay? So you don't need to multiply by the 2. It won't be wrong if you do it. You'll just end up with a number you have to simplify more. So don't do that, okay? So 1 times the square root of 3x will be the square root of 3x. And then this will be 2 times that. 2 times the square root of 9x squared, which is going to become the square root of 3x over 2 times the square root of 9 is 3. The square root of x squared is x. So this will be the square root of 3x over 6x. Again, we can't divide those because 1's in a radical, 1 is not. Okay? And that is how you rationalize a denominator. Okay? Important to know that. All right, you guys have a worksheet in Google Classroom, and then I will see you guys hopefully in person again soon, but if not, I'll see you in Zoom. Thanks a bunch. Bye-bye.